Okay, so that example is actually was an example that I gave drawing using something called a quiver plot. So a quiver plot is when you use arrows to describe what the flow is doing, right? So you put the base of the arrow at the location of the coordinate, and you draw the arrow in the direction of the flow or of the velocity vector, and you make its magnitude proportional to how fast, or like the magnitude of the velocity at that point. So a quiver plot is one way to fully describe what is going on in a fluid flow. It's got some problems. It's not like the best. It's not always the best choice of flow, because if you have, let's say you evaluate the velocity at lots and lots of different points, it can actually become really hard to read these plots because each arrow has to get shorter so that you can actually see them, or if you make them too long, they start overlapping one another. So they're not like a perfect way to describe a flow, and they're actually not super common, to be honest. Um, I'm showing an example of one over to the left here that is the velocity field around a cylinder. And I'll show you some different ways to describe a velocity field around a cylinder, but this is one way, a quiver plot. So quiver plots are not super common, but they're common enough that you should know what they are. In case you're curious, and I'll probably ask you to do some kind of example computationally at some point. A quiver plot is available in all basically common, the two common languages that we'll be using. So MATLAB, the command is just quiver. And in Python, it's actually also quiver. It's just buried underneath the matplotlib.pyplot object space, or module. And so both you can do quiver plots in both MATLAB and Python fairly easily. So basically, all you need to do is specify the x and y coordinates, or maybe even x, y, and z coordinates of the base of the arrows, and then give it the components of the arrows and the other three. So you might have like a list of x and y coordinates, and a list of vx and vy, or equivalently u and v velocity components that go into that. So I may do an example to show you how to do that, or I may just ask you to look up the documentation for those functions that are in MATLAB and Python.